this video, we talk about intake manifolds. Specifically, what I had to do to this manifold to get it ready for the all-aluminum 588 cubic inch B1 engine that's going into my 1964 Plymouth Fury. She's my high school sweetheart. I've had her since 1985, and she hasn't been on the road for 15 years. The whole idea of this channel is to help motivate me to get out in the garage and get things done. And in the process, I was hoping that it may help motivate you to get things done as well. Stick around till the end of the video where I talk some weird stuff about intake manifold theory, and I describe to you what I call the idea of managing the air column. I'm going to show you how I blend the top of this manifold and under the spacers to ensure that turbulence is held to a minimum. What we're trying to do is increase the amount of airflow that's going in a single direction. And the way we're doing it is by eliminating sharp edges that cause turbulence. Let's mock up the passenger side of the engine by building some shims, putting the cylinder head on that side. What that's going to do is simulate having both heads at the right height, and then we'll set the intake gaskets in place, set the intake manifold on, and see what kind of misalignments we have. And I know we'll have some issues. It's a custom handmade intake manifold that was built for another block. Chances are that block may not have had the same deck height, it may not have had the same head gasket thickness, it may not have had the same intake manifold thickness. And if you change any one of those things, your port match is now off and you have to make an adjustment.
All right, here's a little trick that I like to do when it comes to mocking up the cylinder head onto the block. Make a couple of shims just to simulate the compressed gasket thickness. And then tape each piece in place. You need like 4 of them is all. And pistons, every time I look at them pistons, I can't believe it. Those things are so gorgeous. Nothing too precise here. And then just set the cylinder head over the top of the 4 pieces of gasket material. And get yourself a feeler gauge of the right thickness. In this case, 40 thousandths, because that's the compressed head gasket thickness. Just seeing how the gasket fits the manifold. The problem this manifold had on its previous engine is it was sitting on the bolt threads. So it probably wasn't getting pulled down all the way. Those thread marks definitely tell you a story that it was pinching down on them pretty good. Put a little bit of layout dye on each of the bolt locations. I just threw a number out there of 100 thousandths. I'm just going to slot each of the holes 100 thousandths just to make it to where no matter what gasket I end up having to put on it, it's not going to hit. Scribe a little line here. And then we're just going to clamp the intake down and go at it with a rat tail file. nice and sturdy. I totally forgot to push record. And I got no footage of actually filing the holes by hand. Not that everybody needed to see that, but just going back through and straightening out some of the port work. Rolling out the ports. There's not a whole lot of porting you can do on a sheet metal intake because the runners are really thin. The upside is how amazingly lightweight these manifolds are compared to cast aluminum intakes.
This intake smells like old race gas. How about a shout out to Daryl for scoring this manifold for me. Thanks, Daryl. I appreciate it. I love all the people that I've met doing this project online. I feel like I've met so many really cool, like-minded people, but we have this common interest of hot rods and race cars and sometimes even big block Mopars. It's fun to share ideas and parts and so the particular motor that this was on, you can kind of tell that at the end of its life it was struggling. You know, maybe things weren't going so well for it anymore, you know. That happens sometimes. So we're gonna get this thing cleaned up and get the port alignment squared away. It's nasty.
How are you going to get that cleaned up?
I don't know. I'm trying to figure that one out.
Well, I'm going to run up to Summit. If you need anything else, text me.
Oh, sweet. Oh, thanks, man.
I love you.
Love you. Drive safe.
I will.
Is she gone? Sounds like the coast is clear. Let's just sneak this into the kitchen.
go check. Hang on. Yeah, no, it looks really good. Yeah, it's gonna work amazing. Yeah.
So Dave was asking me about this intake manifold that I was building for Garrett, my son.
Probably go 1 inch. Half inch looks a little shy. It does have a pretty. Problem is the front side. Front side's a little shallow.
We get the BS in. We can just go on and on.
Oh shoot, Ash is home. I gotta go.
Yikes. Just in the nick of time. All right, got to get this top plate cleaned up. Just to hit it with a little DA sander. And then put a Scotch-Brite pad on it, hit it again. Carburetor studs, I decided to use these stainless steel button head bolts. And screwing them in from the bottom side up. It was fun editing this. I like this little high-speed stuff. All right, snug these spacers down. And then turn it over and look at the area that we need to work on. You can see that trip edge right there. And you really don't want your air column to recognize that trip edge. So we're going to disguise it. So we need to cut a radius around the perimeter of each of these openings. First thing I'm going to do is I'm going to make a quick radius gauge. So that way everywhere I grind, I can grind it to the same contour, just to make it look nice. Let's take a rat tail file and put a radius on a piece of aluminum. I'll use that one on the left. More layout die. Now we're going to scribe a line around the outside edge using the calipers. And we'll just shape this radius to that line. Just cut and shape it with a carbide cutter. Using wax to lubricate it and keep the aluminum from building up inside the cutter edge. And then here just cartridge roll out the finish. And this is going to allow for that air column to come out of that 4-hole spacer without inducing a bunch of turbulence that would make fuel fall out of suspension at low speeds and create little drivability problems and stuff. Plus it makes it a little lighter. So here's the finished product. Now, if you were an air column, wouldn't you like to come through there nicer than if you were having to negotiate that 90-degree trip edge that was there previously? Back in the old days, we had to build all these 4-hole spacers, these tapered spacers. We had to cut those by hand. It's nice that you can buy these 3D printed versions now for really cheap. All right, let's clean up the gasket surface here. Just going to put a little thin bead of silicone sealant along the flange here. Pretty foolproof way of sealing this thing up with that phenolic spacer, you know, in between the two pieces of aluminum. What I didn't show is I had sanded that flange also before I cleaned it up, just to rough up the texture to give the silicone something to bite into. It's just a giant area that could be a really bad vacuum leak if it did not seal up.
tells you more about the engine builder's intent than the intake manifold. When you walk up on an engine, sometimes that's the first thing you see. It's right on the outside, right on the top. And when you look at it, you know right away what the engine builder was trying to do. Whether it's a nearly stock dual plane intake that's designed to make good low end torque and have throttle response and fuel economy and all that kind of stuff, or if it's a single plane race manifold designed to push torque curve higher in the RPM range, or if it's an all out hand fabricated sheet aluminum tunnel ram. An intake manifold is specifically designed to move the air column straight over the intake port. Number 1 intake port and number 2 intake port offset by the width of a connecting rod. And in order to get the air column to line up with the intake port, we need to rotate the carburetor flange just enough so that way we can get every single carburetor venturi perfectly aligned with every single intake port. The job of the intake manifold is to manage the air column. That's what it does. Besides holding the carburetors up, it manages the air column. The air column is working off of atmospheric pressure. That's the pressure all around us, 14 point whatever pounds depending on what the weather is. That pressure is what's trying to enter the cylinder as the piston drops. The piston drop is the very first thing the engine does. You hit the starter, turns the crankshaft, pulls the connecting rod and the piston down. That creates low pressure. Atmospheric pressure is trying to enter the cylinder. Now, the whole idea for making horsepower is to get as much of this air column into the cylinder as possible. The problem is, every time you turn the air column or change direction in the air column, it has a slight measurable reduction in cylinder filling. When the valve's shut, what you have is what you have. Did you fill that cylinder enough? That's what we're trying to do, is fill that cylinder. The more air and fuel we can get packed into the cylinder, the more horsepower we're going to make. That translates into cylinder pressure. I like to call it dynamic cylinder pressure. I also like to refer to the atmospheric pressure as the atmospheric supercharger. Managing the air column, trying to get as much of that air pressure into that cylinder, that's how you make more horsepower than the next person. If packaging the engine was not an issue, then every single engine would come with a top-fed tunnel ram style intake manifold. Because of packaging, the intake manifold tends to be the first thing to get compromised. So if our goal is to make as much horsepower as possible and to feed the intake port as directly as we can, what we're going to do is make sure that our intake runner is at the exact angle as our intake port. A lot of engines suffer from this. Any narrow valley, low intake port cylinder head. So if you look at, say, a production style big block Chevrolet, even that big 990 head back in the day, or the L88 aluminum head, or whatever, you take those intake ports, which were substantial in size, and if you move that port flat in the cylinder head so that way you can get the carburetor on your Corvette low enough to see over the hood, well, what you're doing is you're limiting the air column's ability to get past the valve and into the cylinder because of the angle of approach the air column has to the valve. In a wider valley engine, like say a tall deck big block Mopar, the intake ports are further apart. So in the case of the B1 cylinder head, as you stand the intake port up to get a better shot at the valve, now you have more room to have your intake manifold coming in at the same angle as the intake port. If you run a big block Chevrolet with a tunnel ram on it, you have that low intake port, and then your tunnel ram comes down and you have an intersect angle where the tunnel ram meets the cylinder head. Air column goes one way, fuel goes the other way. Air column runs into the floor of the intake port and all kinds of chaotic things. Whereas in the case of the B1, you have a raised intake port and a real wide valley on a tall deck engine. You have the ability to build an intake manifold that aligns better with the intake port. And that is a design advantage to the B1 Mopar. Alright, that was a pretty fun video to make. Almost got in a little bit of trouble from Mrs. Griffiths. I got carried away on the phone. Thanks for following along. Thanks for watching. I'll see you guys on the next video. Cheers.